Welcome to today's webinar. I'm Tim Stewart from Visual Decisions, and I've spent decades helping companies transform their operations using lean manufacturing and cutting-edge digital tools. Over the next 20 minutes, we'll explore how to drive smart manufacturing adoption and how you can create a more agile, efficient, and resilient operation. Let's get started. What you'll learn today is, first of all, understanding resistance to change, why people hesitate to adopt new technology, and how different stakeholder groups view adoption. How to overcome Big Brother syndrome, how to address concerns about monitoring, control, and trust in technology, how to foster a culture of adoption, engaging stakeholders, starting small, scaling up, and integrating smart manufacturing into standard work, and then change management best practices, strategies for crossing the chasm from early adopters to mainstream adoption and sustaining engagement. So let's get started. As organizations move towards smart manufacturing, they often focus on technology, automated systems, AI analytics, and industrial IoT solutions. While these innovations can revolutionize operations, they also introduce a significant challenge: human resistance to change. The success of any digital transformation depends on how well employees at all levels accept and integrate new technologies into their daily workflows. Understanding why people resist change and addressing their concerns proactively can make the difference between a smooth transition and a stalled initiative. So, why do people resist new technology? Resistance to change is a natural response, especially in industries where established processes have been refined over decades. One of the most common fears is job displacement. Many workers worry that automation will make their roles obsolete. Additionally, employees may be skeptical about the effectiveness of new technology, especially if they have seen past initiatives fail or introduce unforeseen complications. Others may find new systems complex and overwhelming, creating anxiety about learning curves and potential productivity losses. But beyond these personal concerns, there are often organizational and leadership gaps that contribute to resistance. If employees do not understand the purpose or direction of smart manufacturing initiatives, they may see them as unnecessary disruptions rather than improvements. Poor communication about the strategic goals behind new technologies can lead to confusion, misinformation, and skepticism. Employees may also resist change if they believe new systems are being imposed without their input, especially if past initiatives have been poorly executed or failed to deliver the promised benefits. Additionally, if digital tools do not align well with the existing workflows or feel like extra work, adoption will be slow, and employees may develop workarounds that bypass new systems altogether. So, how do you recognize the emotional and psychological barriers? Adapting to smart manufacturing is not just a technical transition, it is a cultural and a mental shift. Many employees have developed deep expertise in their current roles and processes, and the idea of changing them can be very intimidating. Cognitive biases, such as a preference for familiar routines, status quo bias, or past negative experiences with failed implementations, can lead to hesitation and skepticism. Employees may also feel a loss of control when new technology dictates how tasks are performed rather than relying on their own judgment and expert experience. Change fatigue is another significant barrier, especially in manufacturing environments where process improvements, cost cutting measures, and operational shifts frequently occur. If workers feel that previous change initiatives have been disruptive or ineffective, they may approach smart manufacturing adoption with reluctance. Trust in leadership also plays a role. If employees believe that changes are being made purely for financial gain without considering their impact on the workforce, resistance will likely increase. Smart manufacturing affects different roles in different ways, meaning that resistance is not uniform across the organization. To drive successful adoption, leaders must consider the unique concerns of each stakeholder group. The executives are typically focused on return on investment, efficiency gains, and staying ahead of the competition. While they may see smart manufacturing as a strategic advantage, they may underestimate the cultural and workforce challenges involved. Managers are tasked with implementing new systems while maintaining productivity. Their primary concerns include how these changes will impact KPIs, production schedules, and employee engagement. Frontline workers often feel the most direct impact of the change. They may worry about job security, increased workload, or insufficient training to keep up with the new processes. Without clear communication, they may see smart manufacturing as a threat rather than an opportunity. IT and OT teams are responsible for ensuring smooth integration between the new and legacy systems, addressing security risks, and maintaining system stability. Their resistance may stem from concerns about infrastructure compatibility and resource constraints. Support functions such as engineering, quality, maintenance, etc., play a crucial role in sustaining manufacturing operations. They need to ensure that new technologies align with existing processes, meet compliance standards, and do not introduce additional complexities. Engineers and quality teams may also be tasked with troubleshooting and fine-tuning new systems, adding to their workload. Understanding all of these perspectives is critical for ensuring that smart manufacturing adoption is approached with empathy, communication, and a well-structured strategy. Addressing these concerns early can prevent roadblocks and create a smoother transition toward a digitally enabled future. As smart manufacturing technologies become more prevalent, employees often express their concerns that these systems are designed to monitor and control their work rather than support and empower them. This fear, commonly referred to as Big Brother syndrome, stems from the perception that new digital tools will be used for surveillance, micromanagement, and punitive oversight instead of enabling efficiency and improvement. To ensure successful adoption, organizations must proactively address these concerns and build trust in how technology is implemented and used. One of the primary reasons employees resist smart manufacturing technologies is the perception that data collection is used to scrutinize individual performance rather than optimize processes. Workers may worry that increased visibility into their actions could lead to unfair evaluations, increased pressure, or even job insecurity. This fear is especially strong in environments where past performance tracking initiatives have been used to enforce strict productivity quotas or discipline employees. Additionally, loss of autonomy plays a significant role in resistance. Many experienced workers take pride in their ability to problem solve and make real-time decisions based on their expertise. When digital tools dictate how tasks should be performed, workers may feel disempowered or micromanaged, leading to frustration and disengagement. Without clear communication about how these technologies will support, not replace, their skills, employees may view smart manufacturing solutions as a way to exert greater control rather than enhance their roles. To overcome these concerns, organizations must frame smart manufacturing technologies as tools for efficiency and support, not oversight. Instead of focusing on data collection for managerial control, the conversation should highlight how these tools help workers perform their jobs more effectively, reduce repetitive tasks, and improve decision making. One key approach is demonstrating how data enhances problem solving rather than replacing human judgment. For example, rather than using performance metrics to penalize workers, data can be leveraged to identify bottlenecks, inefficiencies, and areas for improvement, giving employees the tools they need to make informed decisions. Additionally, transparency in how technology is used is critical. Employees should have clear visibility into into what data is being collected, who has access to it, and how it will be used to support both the workers and the organization as a whole. So, what are some practical steps to build trust? Building trust in smart manufacturing adoption requires intentional communication and inclusive decision making. Organizations can take several key actions to ensure employees feel secure and supported. You must clearly communicate why and how data is being collected. When employees understand the purpose behind digital tools, whether it's to improve safety, optimize workflows, or reduce errors, they are more likely to trust the system. Involve employees in defining how technology benefits their work. Engaged workers in the planning and implementation process ensures that digital solutions address real challenges rather than feeling imposed from the top down. And then ensure leadership models responsible data use. Managers and executives should actively demonstrate that collected data is being used to improve processes rather than penalize individuals. By prioritizing transparency, collaboration, and empowerment, organizations can shift the perception of smart manufacturing from a monitoring system to an enabling tool, increasing adoption and driving long term success. Implementing smart manufacturing technologies is not just a technical challenge, it's a cultural transformation. Without a strong adoption strategy, even the most advanced digital tools can face resistance, slow adoption, or underutilization. To ensure success, organizations must proactively engage stakeholders, create a clear vision, start small, integrate with existing processes, and build trust. A well structured approach will make smart manufacturing feel like an opportunity rather than a disruption. The success of any transformation depends on early and active involvement from all levels of the organization. Smart manufacturing adoption should not be dictated from the top down. Instead, it should be a collaborative effort that includes leadership, managers, frontline workers, and support functions. Forming cross functional working groups allows employees to provide input, test solutions, and shape the implementation process. When employees feel like they have a voice in change, they are far more likely to embrace it. A successful smart manufacturing initiative needs to align with the company's broader values, workforce priorities, and operational goals. If employees view digital transformation as a cost cutting measure or a way to increase surveillance, resistance will grow. Leaders must communicate how these tools will improve work quality, enhance safety, and create opportunities for skill development. To ensure a structured rollout, companies should develop a manufacturing strategy and roadmap that incorporates cultural shifts, process improvements, and technology adoption. This roadmap should balance long term goals with short term wins to build momentum while allowing for adjustments based on employee feedback and real world implementation challenges. When workers see a well thought out plan that includes them, trust in the process increases. One of the most effective ways to drive adoption is to start small and prove success before scaling up. Rather than launching a company wide initiative all at once, organizations should begin with a small set of use cases that deliver quick wins for a targeted group. These successes build confidence, allowing other teams to see the benefits firsthand. And then, as credibility and value becomes evident, the initiative can gradually expand to include more teams, departments, and functions. Each phase should focus on solving real challenges for employees rather than simply rolling out technology for its own sake. By building a momentum effect where each successful implementation builds on the last, adoption becomes a natural, scalable process rather than a forced change. As an example of this, for an IoT rollout, it's very natural to start with the production team and implement use cases for production, whether it's machine monitoring, putting visual controls in place, etc. Once you have that production team running more efficiently, the natural next extension may be to work with the maintenance teams and integrate that data into how maintenance does their jobs. And this may be things like enhancing preventive maintenance, looking at predictive maintenance capabilities, and things like that. Next, you may expand the focus to the quality team. And the production information that's coming from these IoT systems can certainly be used in root cause analysis and other quality initiatives. And now that you have that focus expanded to the quality team, you're going to see more and more value and more success from the implementation. Next, you may start to look at use cases for safety, for planning, for supply chain, materials movement within the factory, and so forth. Then you can start to look at how you integrate this information into giving finance a more detailed view of what's happening on the shop floor, designed for manufacturing processes and other use cases within the broader organization. And even beyond that, to organizations outside of your own four walls. So by starting small, by starting with a focus group and focused use cases, you can build that momentum and carry that across the organization. And something that shouldn't be overlooked is integrating with standard work and leader standard work. For smart manufacturing to be sustainable, it must become a seamless part of daily operations rather than an additional burden. This means embedding digital tools into the existing lean and standard work processes. When employees see technology supporting and not disrupting their workflows, they are much more likely to adopt it and rely on it. A critical element of integration is leader standard work, which ensures that managers and supervisors actively use the digital tools in their coaching, problem solving, and decision making routines. Leaders must model the behaviors they want to see, demonstrating how smart manufacturing enhances operations without replacing human expertise. Companies that evolve their best practices rather than replacing them outright will see much higher adoption rates. And a workforce that feels empowered and supported is far more likely to embrace change. Employees should be actively involved in the solution design and testing, ensuring that new technologies address real pain points rather than creating new ones. Upskilling and training programs should focus on building confidence, helping workers see smart manufacturing as a tool that enhances their abilities rather than threaten their jobs. Finally, without trust, even the best smart manufacturing initiatives will struggle. Transparent, open communication is essential for addressing concerns, reducing uncertainty, and reinforcing the benefits of digital transformation. Leaders should use real success stories to highlight positive outcomes and address skepticism, Employees need to see concrete examples of how these changes make work easier, safer, and more productive. Leadership must take an active role in setting the tone for smart manufacturing adoption. If managers and executives embrace and advocate for digital tools, employees will follow their lead. A culture of trust, transparency, and engagement will ensure that smart manufacturing is seen as an opportunity rather than a disruption. Successfully implementing smart manufacturing requires more than just new technology. It demands a strategic approach to change management. Even the most well designed digital transformation efforts can fail if employees resist or fail to see the benefits. To drive adoption, organizations must identify internal champions, secure buy in, reward engagement, and bridge the gap between the early adopters and the mainstream, and then sustain that long term participation. One of the most effective ways to encourage adoption is to find those internal champions who can advocate for the transformation. These are the employees who are respected by their peers, embrace innovation, and can positively influence others. Champions act as connectors between leadership and frontline teams, helping to translate technical benefits into practical day to day improvements. Rather than relying solely on leadership to push change, peer advocacy accelerates adoption by making new systems feel more natural and beneficial. Employees are more receptive to guidance from colleagues who understand their daily challenges. Establishing a network of champions across different departments ensures that adoption is supported at all levels of the organization. Resistance is natural, but organizations can proactively address common objections and concerns to prevent roadblocks. Employees may be skeptical about how smart manufacturing will impact their roles, their workload, or job security. To gain buy in, companies must clearly communicate the purpose and expected benefits of the new technologies, provide quick wins that demonstrate immediate value to workers, align smart manufacturing initiatives with employee priorities, such as making work safer, reducing repetitive tasks, and improving efficiency. When employees see that smart manufacturing is designed to support their success rather than replace them, they're far more likely to engage. Recognizing those who actively participate in smart manufacturing adoption is essential to maintaining the momentum. Employees who embrace new technologies early can influence others, so rewarding their efforts reinforces positive behaviors. Think of incentives for engagement. These can range from public recognition to tangible rewards, such as bonuses, promotions, or additional training opportunities. Celebrate small wins, highlighting success stories such as efficiency improvements, fewer errors, or improved working conditions helps to reinforce the value of smart manufacturing. And showcase those early adopters, featuring employees who have successfully leveraged digital tools to improve their workflows encourages others to follow suit. A culture of true appreciation turns early adopters into advocates, making it easier to scale adoption across the organization. One of the biggest hurdles in digital transformation is moving from a small group of early adopters to company wide adoption. While early adopters are naturally inclined to embrace new technology, the majority of employees may be hesitant, skeptical, or require more hands on support before committing. To bridge that gap, organizations must leverage the early adopters as mentors and advocates to help them guide their peers. Demonstrate tangible success metrics to build credibility and confidence. Adapt messaging to align with the mainstream workforce priorities, focusing on practical benefits rather than technical features. And provide hands on support and gradual transitions rather than forcing abrupt changes. And then recognize the tipping point, that moment when adoption shifts from niche to mainstream. It's a critical step. At this stage, smart manufacturing should feel like an integrated part of operations rather than a new initiative. And finally, change management does not stop once adoption begins. It must be an ongoing process to ensure continued engagement and improvement. Companies should establish feedback loops so employees can share their experiences and challenges, regularly adapt strategies based on that employee input to ensure that smart manufacturing remains relevant and effective, and so that people feel heard. Embed digital adoption efforts into long term workforce development so that new technologies evolve alongside those employee skills and business needs. By treating smart manufacturing adoption as an iterative, employee driven process, organizations can maximize engagement, minimize resistance, and ensure long term success. The transition to smart manufacturing can be complex, but by focusing on engagement, transparency, and gradual adoption, organizations can accelerate the implementation while minimizing resistance. The most important lessons from this discussion include: people are the key to success. Understanding why employees resist new technology, whether due to job security concerns, a lack of clarity, or fear of change, allows organizations to address these challenges proactively. Trust is essential. Overcoming Big Brother syndrome requires transparent communication, ensuring employees see digital tools as supportive rather than punitive. And early engagement drives adoption. Fostering a culture of smart manufacturing adoption starts with involving key stakeholders from the beginning and aligning new technology with company values and workforce priorities. Scaling adoption requires strategy, starting small, demonstrating quick wins, and expanding those successful use cases builds momentum while minimizing disruption. And then crossing the chasm is critical. Moving from the early adopters to the mainstream acceptance requires leadership support, peer advocacy, and tailoring the implementation approach to the needs of the different employee groups. So, in conclusion, adopting smart manufacturing is a journey, and taking the right first steps will determine long term success. Our strongest recommendation for getting started is to leverage the SESME Smart Manufacturing Acceleration Framework. It's a proven approach for creating a comprehensive roadmap that integrates the cultural, process, and technology aspects of digital transformation. This framework ensures that organizations don't just implement new tools, but embed them into the daily operations in a sustainable way. To continue this journey, connect with us on guidance for driving adoption in your organization. Let's connect. If you'd like to learn more about how to drive adoption in your organization, please contact me for more details through any of the methods on the screen. The QR code will take you to the Visual Decisions website for more information. Thank you again, and we look forward to seeing you in future sessions.